I'm very happy to have the chance to introduce, with this speech, the new technology and new process that we introduced that is related to casting of bars, kilo bars and smaller bar, with a new process involving a mechanical sand as an intermediate product. First of all, in this presentation, I will spend a few words about the Perth Mint, that is the co-author of this paper, as well as a few words about IKOI as a company, and then I will review the technology that is most commonly used to cast kilo bars and smaller bars at the moment, and after that introducing the new process that we develop using a mechanical sand that we call Sandance. The last part of the presentation will give you some data and some results of the test that we conducted between IKOI and the Perth Mint and the comparison between the two processes with the advantages and a look at the future development. First few words about the Perth Mint, even though I'm quite sure that you know it very well. It is the Australia largest fully integrated precious metal enterprise. They provide refining, bullion, coins. It's a company with 126 years of history, and it is an LBMA approved refinery for both gold and silver, as well as one of the few good delivery referees. And they have a booth, obviously, at the exhibition as well. From the IKOI side, we are an Italian company. We are based in the northeast part of Italy, and we are technology providers for the precious metal industry, so for the refiners and the mints. Over the years, we introduced a number of innovative technology that change somehow the way the refineries operated, including the first tunnel furnace for bar casting, the flameless tunnel, the acidless separation system that is capable to separate silver from gold without the use of any acid, and a range of fully automated systems for casting and melting. Specifically, in the last year, we are focusing our attention on changing some processes within the refining, replacing thermal process, so melting process, with mechanical processes, because we can see a lot of advantages in there, both for the casting side and for the refining side, thanks also to the acquisition of OPI, which is a specialized company that designed chemical and electrochemical plants. Now, going a bit more in details about this presentation, I will introduce what we have developed as a system to cast silver bars without going through grains or granules as intermediate product. To give you an overview, the most common technique used today to cast bars from 1 kilo and less requires the production of gold and silver granules that are then put into pure graphite molds. These molds are run through induction furnaces, such as our compact, and get the final product as a finished bar. This is very common now in the industry. I would say that it's probably the most common technique in the industry. To apply this process, you need to produce granules as an intermediate product. Very common for the refiners, and it's an activity that is done on a daily basis, but it is an activity that has some drawbacks, namely, and first of all, the energy consumption. It is an energy-intensive process because obviously you have to melt the feedstock, pour through a dye that is typically made of graphite, and then into a tank of water to get your grains and then dry them. So energy required to do these activities is quite intensive. And also there are some other two main drawbacks. One is the use of consumables that are part of the cycle. So the crucibles, the dies, and all the components that are very close to the melting part are wearable parts, and that increase the operating cost of the activities of producing the cast bars. And there is the residual hazard in this operation. Now, the refineries are all really good in handling these kind of risks, but nevertheless is something that has to be taken into account because we are dealing with molten metal, with high temperature, and we are actually pouring the metal into water, which is in itself an operation that has a residual risk. So what we are proposing in terms of innovation is replacing this process with a mechanical process and taking the material that is coming out from the refining of silver, process it mechanically to create an intermediate product that is not granules, but it is a mechanical sand that we call Sundance. This is done using our technology, a machine called Density Booster, that solves two problems with the feedstock. The first one is removing the residual moisture that is in the feedstock, and the second one is increasing the bulk density of the media. This means that we go from, to give you some numbers, a bulk density of the silver crystal that is between 2.8 to 3.7 kilograms per liter, and we increase this bulk density to 4.9 to 5.8 kilograms per liter, which is very, very close to the bulk density of the granules. So that allows us to replace the granules with the sand, and this is a short video of the Perth Mint actually producing bars with this intermediate product rather than granules using one of our machines. The only slight modification that they had to do is in the molds to account for this 10% difference in the bulk density. And these are some examples. The Perth Mint is already operating using this process, and the two bars that you can see on the top are done using the traditional method using granules, and the two on the bottom are done using the Sundance process, and the quality is exactly the same. There is no difference into the two processes in the final product. Together with the Perth Mint, we also set on a journey not only to define the technology that is needed to implement this process, but also the basic parameters that are required for it. So for all the job that we have done with them, we work with the silver that is a 4.9 because it is their standard. They operate only on 4.9 silver. And after that, straight from the electrolysis, there is a 28 minutes washing and rinsing of this crystal using only water. And after that, a drying process of 15 minutes at 60 degrees. After that, the feedstock is ready for the density booster to create the Sundance, the mechanical sand, at the rate of 120 kilo per hour. The size of the sand that we are producing is a bell curve that is around 300 micron, so it is technically not powder. It's big enough to flow, to be handled very easily, and with a granulometry that is smaller than the granules, obviously. Without going into details, this is a snapshot of the process comparison between casting bars using grains and Sundance, and visually it is quite obvious that we are skipping one part of the process and we are avoiding the melting and the pouring for the production of granules. And I want to spend a few minutes about this slide because this is actually where we are drawing our conclusion and our comparison between the two processes and highlighting the advantages. First of all is energy consumption. There is an order of magnitude difference between the process using grains and the process we're using the mechanical sand. To give you some numbers, approximately for every kilogram of silver granules that you produce, you need 1.6 kilowatt hour, which is reduced to 0.17 kilowatt hour for the kilo of mechanical sand that you're going to produce. You are removing the hazard of high temperature and molten metal and liquid. as well as the complexity of the operation is reduced significantly. The melting and casting operation is a medium complexity operation. You require a foundry operator. The mechanical sand is a low complexity operation. Any operator can actually activate the machine and produce the sand. Productivity in terms of capex is also higher, but the most important advantage is that the operating cost of this process is significantly lower, and this comes from two considerations. The first one is energy. There is an order of magnitude of saving in terms of energy. And the second one is the consumable consumption that is very much reduced in the sand-dance process compared to the traditional process of using crucible and dyes and everything that is related to the foundry operation. So these are the advantages of the system. The technology and the system is commercially available. So if you want to have more information, you can talk to me at the networking or come to our booth. I give you also a hint about the future development that we are taking. This technology is commercially available for silver. We are working on the research and development stage to apply the same or similar technology also for the gold, taking the material that is coming out from the refining process, specifically from the wet process, the aqua regia process.